Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our water flood playlist and still about water flood-induced fracture. And today's topic is about behavior of producing well along the fracture direction. Before jumping into the topic, if you think this channel or this particular video is useful, please support this channel by clicking the like button and subscribe. Okay, so let's go. All right, again, I will use the material from this very interesting and quite short paper. You can find it on the internet and download it. The title is Comprehensive Evaluation of Water Flooding Performance with Induced Fractures in a Tight Reservoir. It's a field case from China. And we have two pictures here. The first one, you can see the pie chart, or maybe you can also call it bubble map. Okay, the pie chart of production of well pattern L33-35. This is the producer under investigation. And the blue bubble here shows the injector. And you can see the name of the well there at the top section or above the pie chart. And for the producer, it is colored red and green. Red color shows the oil contribution, oil fraction, or oil production rate, whereas the green color shows the water. And we can also check this second picture. This is the vertical flooding extent of L3335, which is the producer, between two injectors. The injectors here is L3236, which is this injector, and this is the logging profile, and L3434, which is here. And the logging profile is here. Okay, so that's the, that's the case that we have. We have one producer, L3335, which is located between two injectors, L3434 and L3236. And if you read the paper, the author gave us information that basically the maximum horizontal stress or the maximum principal stress direction is aligned this direction, northeast to southwest, right? Northeast to southwest, which is in line with the alignment of this producer and the two injectors, which means this well is now in danger, all right? Because this is the maximum principal stress direction or the direction along which the fracture will be propagated, will be extended. Okay, and in previous videos, I also already talked that most water flood, especially in tight water flood, will have water flood-induced fracture, generating mainly from the injector because you inject something at high pressure, it will generate fracture. It will create fracture, and the fracture will be propagated along the maximum principal stress direction, which is here. So let's say we have fracture from L3434, and the fracture will grow, propagate until it reaches this producer L3335. And the same thing with L3236. It might have fracture, and the fracture will be propagated along this direction. Okay, and this is the easiest path of water floods induced fracture extension. That's why in this paper we have high water cut. You can see from the green color dominating the pie chart, and you can compare it with other producers. Other producers have oil as more dominant phase than the water. You can see L3236, the oil is quite good. L3334, oil is greater than water. The same thing with 34, 35, 32, 35, this one and this one. Only L33, 35 has water dominating the oil. Why? Because it is located in line with the fracture extension direction. Most likely, this producer has been connected with the water flood-induced fractures generated from the injector, from the two injectors. Okay, so that's the main thing which is very important. If you have water flood right now, if you're managing water flood asset, especially in tight reservoir, please be careful. You need to focus on producer which is located along the maximum principal stress direction, especially if they have adjacent injectors at that direction, at that alignment. Okay, and you can see here the last thing, producer L3335 is high water flooded because it is located between the two injectors along the maximum principal stress direction, which is generally the easiest path of water flood-induced fracture extension. And if I zoom in, we have this one. This is a good picture. Basically, you have gamma ray and spontaneous potential log, and this is the perforation, the completion, and you can see the red color and this yellow orange color. I think it shows the sand connectivity. And this is the perforation of the injector. You have two perforations and also two perforations for the second injector and two perforation for the producer. Okay, and then L3236 has fracture, injects water, and the water will move mainly along the fracture. Okay, so the water will easily reach L3335 and the same thing with L3434. Okay, so that's why you have this remark, high water flooded, high water flooded. Okay, especially at this perforation depth, which is not good, not good at all. Okay, and to make sure to be sure about this, you can run, of course, the logging. Okay, you can run injection logging at L3236 and 3434, and you can also, perform production logging at the producer, so you can know which perforation, which interval give you, the highest production and which give you the lower production. And you can also perform saturation logging to identify which interval has the highest water saturation and with still remaining oil saturation, something like that. So you need to perform production logging, injection logging, and saturation logging. Okay, so I think that's all. Again, the main thing is we are looking on the behavior of producing well along the maximum principal stress direction. Majority of water flood, especially in tight reservoir, will have water flood-induced fracture, and the fracture will be propagated along the maximum principal stress direction. So if you have the alignment of producer and the adjacent injector at that direction, then the producer will be in danger because the fracture will be generated from the injector and the fracture will be propagated, will be extended towards your producer along with the maximum principal stress direction. Okay, so I think that's all. I hope you enjoyed this video. I hope this video is useful. Thank you so much for watching. See you again in the next water flood videos. Thank you.